we should probably do the Argonia video at some point.
Yeah, we really should.
Alright, let's go to Connor.
Let's go get Connor.
Do you remember the code?
No, do you?
I think it's
Hey, there he is.
I knew he'd be in here.
Let's go get Robert.
Yeah.
Let's go get Robert.
Sit and meet us outside.
Okay.
There he is. Hey, Robert. Bye, Robert. Bye, Robert.
Hi, I'm Cameron Ferrarini, and I'm a senior in mechanical engineering at the University of Wyoming. I'm part of a 4-man senior design group whose goal is to go to the Argonia Cup in March and win. To do this, we're going to use a steerable parachute attached to a custom flight computer, both of which we've developed and built this year, to bring our rocket back towards the target with the golf ball in tow. Our rocket is made out of 4-inch diameter blue tube with fiberglass fins and a plastic nose cone, and comes out to about 7 feet in length when everything is attached. Well, we're using a 75mm 4-grain motor and dual deploy just in case our main parachute doesn't inflate on the way down. Our flight simulations currently have us going to 12,000 feet, well above our 8,000 foot minimum. And even without the lift generated by our custom parafoil, which because our simulator can't handle that, we're falling slow enough towards the ground that we're safe. And now here's Kevin to talk about our parafoil.
I am Kevin Metters, a senior in mechanical engineering, and I was in charge of designing the parafoil or ram air parachute to guide our payload back to the target destination. For this, we had to design a custom ram air parachute because the commercially available parachutes come in basically 2 sizes. Full human size, which is like what a skydiver would use, or toy RC size, which is way too small for our application. So we had to design and build a custom one. Some of the design considerations we had for building this were we wanted to make sure that it opened reliably and consistently, and so this played a lot into the design of the leading edge, both the angle that the leading edge was at and the dimensions of each of those openings were carefully considered to make sure that we had a reliable open at apogee. Another consideration was the actual airfoil performance, and this controlled things like the thickness of the airfoil, the size, the camber of the airfoil, and all of that to make sure we got proper lift and drag to successfully guide our payload back to the location. When it came to actually constructing this parafoil, we used a ripstop nylon material that was actually a 40 dyner, and we had to custom sew it, so I've been learning how to sew, as you can see.
Connor Leyshon. I'm a senior in mechanical engineering, and I was in charge of creating the flight computer. So the biggest challenges with the flight computer is making sure that we had telemetry back to the ground at all times, and also making sure that all of our components work together. We use a STM32 processor that connects to a magnetometer, accelerometer, and gyroscopes, and also a barometric pressure sensor to determine our altitude, our heading, and our location in space. We also have a GPS unit on it, as well as a LoRa communications board that gives us the telemetry that we need back to the ground.